Greetings, engineers. James Murray here, doing what we do best, which is to equip you with one little hack every day to show you workflow tips and tricks to improve your workflow efficiency. Of course, to make you super productive if you implement these principles, but most importantly, to reiterate the fundamental roles of engineers in a society. One is to solve problems, and in this age and time, we're using technology like the software Civil 3D here, which we'll be using in the next few minutes to solve these engineering problems. Number two is to protect the environment and its people. Number three is to design and build infrastructures that we're going to help the functionality of the society, but most importantly, to assess the risks that may arise from their decisions and put up measures to mitigate these risks. Remember, the decisions of engineers are based from logical reason, use of data, and of course, leveraging technology. What this ensures is we have sustainable infrastructure, and then also we have safety. We ensure safety of the lives of our people and their property. In the last 3 weeks or so, we've had devastating news where floods have claimed the lives of our people and, of course, property worth billions of money. But today, I want us to look at a software, Civil 3D, and how we can use these softwares to make better and informed decisions. Remember, when it comes to storm design, storm sewer design has been one of the most challenging uh, or one thing that has not been considered comprehensively, especially when it comes to urban areas, where we are having combined sewer, where we're combining storm sewer and sanitary sewer, and you see the results is all over the city. I was just putting a context for what we're going to do today. But remember, we are going to have a webinar on Saturday from 8 p.m. where we'll be extensively looking at storm sewer design from an expert from South Africa. He will be gracing the event and sharing the tips that he's been using in their own country to have a better storm sewer. So make sure you check it out. But most importantly, we also have a training that is upcoming on 20th of this month, that is on Monday, where we will be training engineers. We are helping you use technology, improve your skills, and accelerate your career. Today, I want us to prepare the ground for our webinar that is going to be on Saturday. And what we are doing is we are carrying out what we call a surface slope analysis. So to perform a surface analysis, this is where we set the parameters that we need to use. Of course, this is guided by road design manuals and other drainage design manuals. And using these, we are able to analyze the existing ground. And once we analyze this existing ground, then we can make decisions from that. So the procedure is first you should have carried out a topographic survey on that specific area, brought your points and built or modeled or replicated the existing ground on your computer, that is whatever software you're using. So and I can then select the surface. Once I select the surface, there's the contextual ribbon that pops. In the contextual ribbon, I want us to go to the modify panel. In the modify panel, there is the surface properties. Once you open the surface properties, I want us first to go to information. You can see the name of the project, or rather the surface, the style that has been adopted. And then most importantly, I want us to go to the last panel, which is statistics panel. In the statistics panel, you go to the extended. In the extended, this is where you see the surface details. So in this case, we're having the minimum and the maximum slope or grade that we are having, and then the mean slope at that area. So make sure you note down whichever surface, whichever project that you're going to use. And then we'll go back to analysis. The reason as to why I've gone straight to slope is because we're going to do slope analysis. So an interpretation of this data is we have the surface area of our surface. And then we have the minimum slope. So for example, at 0.21% slope, well, that basically what that is telling us is we are having a near flat zone in that specific area. So in that area, we are expecting flooding. And then we have the maximum slope, which is 793, super steep. So we're expecting probably a run of that. Then we have the mean grade slope, which is 3.69, which is something that is around our target. So those are the key things. So I want us to go to the analysis tab. In the analysis tab, we go to analysis type. So you can carry out analysis of your surface or surface analysis with each of the following methods: contours, directions, elevations, slopes, slope arrows, user-defined contours, and watershed analysis. For today, we are going to focus on slope analysis. And then after that, you need to look at what is the expected range of your analysis. So we added it down here. And then in this case, we would want to have a slope of 0%. I want 0% to be up to 0.5%. Why? This is where we are expecting or standing water on our drains. So that's why that was the first choice. Then I can have the scheme or the color zone at that specific, I can maintain red. And then the second zone will be from 0.5%, 0.5%. And in this case, I'll be considering a flat terrain where I can have all the way up to 5%. And then the color code for this one, remember this is the target area, the crossfall is around 4%. So I can make that to be green. And then after that, I'll take a slope from 5%. And on this one, I can go all the way to probably around 10%. That is more of getting to a more of a mountainous terrain. So in this case, I can get to use yellow. Now let me use brown. Here, this brown will be perfectly good. And then from there, I can use 10% all the way to the end. So this is more of a steep zone. And in the steep zone, I can use yellow for that specific case, and then I'll be able to set the preview, and I can see the ranges that I have here. So after that, I get to apply. Once I apply these, then I press OK. So once I press OK, you can see these are not displayed in my surface red. So for me to avoid tampering with this surface, I would like to create a new style that will display the information that I have. So the first thing is I select this surface. Once I select this surface, I go to surface properties again, go to the information tab, and I can see the surface style with contours of 2 meters and 10 meters. That's the interval. Click on this drop down, make a copy of the current selection, and then I can rename it. And this one, this is slope analysis, right? And then once I do that, I will go straight to the display tab. In the display tab, I can see at this point I was only displaying the major contours, minor contours, and user contours. For now, I want to display the slopes, and then press OK, and then apply and press OK. So once I have assigned these surface, I can be able to see, or rather to visualize. So in this case, I want to turn off the contours, select on this one, slope analysis, get to edit the style. So let's edit current selection. I can actually get to turn off the contours, then these user contours as well, and I will be left uh, with the surface only. And if I look at this surface analysis, what I'm seeing is I am seeing a range of all these stations. So the green code was between a slope of 0.5, 0.5 to 5%. And what I'm seeing is I have fairly a good flow. once I get to visualize this, I can see this is within the right of way. Remember, the right of way is the most important zone that we need to make decisions along. So I'm seeing that my slope is around the green zone. If now, for example, you don't understand what the green zone means, for quick reference, we can insert our legend. So to insert our legend, we just select the surface. I go to add legend. So in the add legend, I click on add legend. Then there is a window that is asking me to enter the kind of table that I want to include. So there is the directions, elevations, slopes, arrows, and all of this. So in this case, I want to do slopes. And then there is the behavior of the table. We have dynamic and static. When we talk of the dynamic, it means that anytime you get to modify your surface, then the table will update automatically. So that's the preferred one. And then once I do that, it asks me select the upper left corner to position it. So I would like to position my table somewhere here at the start of the project. So once I do that, I'll be able to visualize and see and remember that sections where I expect to have stagnating zones should be at red with color code red. So I'll skim through and I can see let me escape. They are very minimal. You can see it somewhere like here, a zone here, and it's within my road project. So this means that the Kimber can take care of that section. And also during construction, I would want to know the specific change of that road to rectify. The second thing is I look at a zone where we're having 0.5 to 5%, which is green, and you can see it's probably the second, it's actually the largest area. So this means we are having more of a rolling terrain. We are having more of a rolling terrain. And that means in this project, we don't anticipate to have any flooding or drainage issues because you can see this green zone. It means that water will be draining naturally. And after that, we can get also to visualize and know what is the direction of flow of water in this specific project area. So the first thing is we select the zone, and then once we select the surface, go to the contextual ribbon. There is the surface properties. Once we go to surface properties, we go to analysis again. And now the kind of analysis that we want to know is the slope arrows. Slope arrows are going to help us identify the flow direction in case we are having excessive storm water at that specific point. So I want just to have a range of one arrow and then I will include it. The color here, I can choose the scheme color, and in this one, I can have it in, yeah, I think magenta will be good enough in this case, and then get to apply and then press OK. You can see it has not directly displayed here, so that means we need to modify the style so that it can display those specific ones. So select the surface again, go to the contextual ribbon, and the surface style, we want to display the surface arrows. Apply and then press OK. So what this is showing us is we can get to know how will water be flowing. So this is the main road, and look at it. This is the beauty of it. We can see that the main road has a perfect crossfall. So water will be flowing um, outside the carriageway. You can see within this section, you can see that is a very consistent pattern. So this means the main road here has a perfect crossfall. And then when we come to analyze this, look at where I probably inserted this culvert. You can see water from this zone will be flowing towards this point. It means that this culvert is going to evacuate the water that is flowing from the carriageway. Suppose we have an intersection, which you're going obviously to have at this point. As you go along this project, you can see water from all these catchment area will be flowing towards your road project. So that's why you need to have a very robust drainage system. What you can see is what we've installed along this project road. You can